Hello everyone. In this video we'll discuss about the nodal analysis. Okay, this is a question given. Find the unknown values of voltages using nodal analysis for the given circuit. So here we have one voltage source connected in series with a resistor, another voltage source connected in series with another resistor, and one more resistor is given. Okay. So if we have a voltage source in series with a resistor, then first step what we have to do is we have to convert this voltage source into a current source. Okay. So any voltage source connected in series with a resistor can be converted into a current source in parallel with the same value of resistor. So here we have 50 volts connected in series with 10 ohms. So now we can convert this into a current source connected in parallel with the same value of resistor. Okay, so the same value of resistor we have to write here 10 ohms, and then the current value I is found out by using Ohm's law. By Ohm's law I is equal to V by R. So 50 divided by 10 is equal to 5 ampere. So now the direction, how we can find out the direction, let's discuss that one. Suppose we have the terminals A and B over here. This positive terminal is connected to A and negative terminal is connected to B. So it is always a conventional practice that the current should be marked from the positive terminal of the supply voltage. Okay. So if the positive terminal is connected to the upper terminal, that is A, then we have to mark it in the upward direction. That is, we have to mark the current source direction from B to A. Okay. So this is how we have to mark the direction. Suppose if the voltage is given in this way, okay, if the negative terminal is connected to A and positive to B, then we have to mark the current direction in the downward side, okay, moving towards B. Okay. Similarly, we have to convert this 20 volt source connected in series with 20 ohms resistor into a current source. Okay. So this 20 volt source is connected in series with 20 ohms resistor. So again, suppose this is considered as C and this is D. So this positive terminal is connected to C. So the current direction should be marked from D to C. Okay. So the same value of resistor should be connected in parallel. So here 20 ohms. And here current value is given by V by R. So 20 divided by 20, 1 ampere. So now we have to replace this voltage, these two voltage sources by these two current sources. Okay. So now the circuit will become like this. Okay, this 5 ampere source is connected in parallel with 10. Already we have 40 ohms resistor. This 20 ohms resistor connected in parallel with 1 ampere source. So now we have one common point wherein all the elements are connected. Okay. And then we have one more common point. This is defined as a reference node, which is at 0 volts. Okay. So we have two nodes, one node and another reference node. Okay. So if there are two nodes, then we have to write one node equation. If there are n number of nodes, then we have to write n minus 1 equation. So we have to consider the reference node also. Okay, including the reference node, we have two nodes. So now we have to assume a voltage across this voltage at the node. So let V be the unknown value of the voltage. Okay, here. So now we have to write down the Kirchhoff's current law. So for finding out the unknown value of voltage using nodal analysis, we are going to use Kirchhoff's current law. So by Kirchhoff's current law, we already know that at a particular junction or a point, sum of the incoming current is equal to sum of the outgoing current. Okay. So this is a node or a junction or meeting point of all the elements. So now we have to write both incoming as well as outgoing current with respect to this particular node. Okay. So now incoming current is written with respect to current source. If the current source direction is towards the node, then this is considered as incoming. So here we have 2 current sources and 3 resistors. So the 5 ampere sources towards this node, and similarly 1 ampere source is also towards this node. So both the currents are incoming currents. So if the direction is in the opposite way, then we have to consider them as outgoing only. So now we have 2 incoming currents. So now we have to add these 2 currents. 5 plus 1 will be 6. Okay. So next we have to write the outgoing currents. So we are assuming that currents flowing through the resistors are considered as outgoing. Okay. So first we have to write down the current flowing through 10 ohms resistor. So for that we have to apply Ohm's law. By Ohm's law, I is equal to V by R. So now the voltage across this particular 10 ohms resistor is V minus 0. Okay, V minus V reference. V reference is nothing but 0 volts. So V minus 0 or simply V. So V by 10. So next, current flowing through this 40 ohms resistor, V by 40. Similarly, 40 ohms resistor is connected in between this particular node and the reference node. So V minus 0 by 40 or simply V by 40. And similarly, current flowing through this 20 ohms resistor is V divided by 20. So now we have to add all these. So sum of the outgoing currents will give you V by 10 is nothing but 0.1 V. V by 40 is nothing but 0.025 V. Plus V by 20 is nothing but 0.05 V. So adding all these, we will get 0.175 V. So this is sum of the outgoing currents. So already we have found out incoming current. So by Kirchhoff's voltage law, we have to equate both these. 1 equal to 2 or 2 equal to 1. Sum of the outgoing currents is equal to sum of the incoming currents. So V is given by 6 divided by 0.175. So this will be equal to 34.285 volts. Next we will solve one more problem. This is a given question. Calculate the node voltages in the given circuit using nodal analysis. So in the given problem we have 2 current sources, 5 ampere and 10 ampere sources, and 3 resistors. Okay. So here V1 and V2 are the 2 unknown values of node voltages, and this is the reference node. Okay, reference node will be at 0 volts. Okay. So now we are going to write down the node 1 equation. So in node 1 the elements connected are 2 ohms, 4 ohms, and then this 5 ampere source. Okay. So now we have to write both incoming and outgoing currents. So incoming current is with respect to current source only. If the direction of the current source is flowing towards the node, then this is considered as incoming. So if you see here, this 5 ampere source is flowing towards node V1. So this is considered as the incoming current. So current source 5 ampere is considered as incoming. So now currents flowing through the resistors are considered as outgoing currents. So first we will write down the current flowing through 2 ohms resistor. So this 2 ohms resistor is connected in between node 1 and reference node. So the voltage across this particular resistance will be V1 minus 0 or simply V1. So divided by 2 will give you the current value. Similarly, we have to write down the current flowing through this 4 ohms resistor. This 4 ohms resistor is connected in between node 1 and node 2. Okay. So the net voltage across this resistor will be V1 minus V2 or V2 minus V1. While writing for node 1, we have to consider the voltage as V1 minus V2 divided by 4. So this is equal to V1 by 4 minus V2 by 4. So now we have to add all the outgoing currents. So sum of the outgoing currents will be equal to V1 by 2 plus V1 by 4 minus V2 by 4. On simplification, we will get 3V1 by 4 minus V2 by 4. Now, by applying Kirchhoff's current law, sum of the outgoing currents will be equal to sum of the incoming currents. In this case, sum of the outgoing currents are 3V1 by 4 minus V2 by 4. This will be equal to incoming current 5. So this is equation number 1. Next we have to write down the node 2 equation. So this is node 2. In node 2 we have two current sources, that is 5 ampere source and 10 ampere source, and two resistors are connected. So if you see here, this current is flowing away from the node. This 5 amperes current is flowing away, and this 10 ampere current source is flowing towards the node. Okay. So whenever the current is flowing towards the node, this is considered as incoming current. When it is flowing away from the node, it is considered as outgoing. And the currents flowing through the 6 ohms and 4 ohms are considered as outgoing. So this is reference node. So now we'll write the incoming current. So here the current flowing through this 10 ampere source is considered as incoming because the arrow direction is towards node V2. Whereas this source is flowing away, so it should be considered as outgoing current. So current flowing through 5 ampere source is considered as outgoing. So next we have to find out current flowing through 4 ohms resistor. So now this 4 ohms resistor is connected in between node 1 and node 2 as already discussed. So the voltage across this is given by V2 minus V1 divided by 4. While writing for node 1, we have considered the voltage as V1 minus V2. While writing for node 2, we have to consider this one as V2 minus V1. So this will be equal to minus V1 by 4 plus V2 by 4. So next, current flowing through 6 ohms resistor. So the 6 ohms resistor is connected in between node 2 and the reference node. So the voltage across the 6 ohms is V2 minus 0 or simply V2 divided by 6. So now we have to add all the outgoing currents. Sum of the outgoing currents is equal to 5 minus V1 by 4 plus V2 by 4 plus V2 by 6. So this will be equal to minus V1 by 4 plus 5 V2 by 12 plus 5. So now we have to write down the KCL equation. So by Kirchhoff's current law, sum of the outgoing currents is equal to sum of the incoming current. Here the incoming current is 10. So we can write V1 by 4 plus 5 V2 by 12 plus 5 equal to 10, or minus V1 by 4 plus 5 V2 by 12 equal to 5. So this 5 will go this side. So 10 minus 5 will be equal to 5. So this is equation number 2. These are the two equations we have obtained. First equation 3V1 by 4 minus V2 by 4 equal to 5. Second equation minus V1 by 4 plus 5 V2 by 12 equal to 5. Okay, now we can write it in the matrix form. So in the matrix we have to write down the coefficients of V1 and V2. And on the right hand side, this is the current matrix as we have discussed previously. So 3 by 4 minus 1 by 4. Similarly, second row minus 1 by 4, 5 by 12. Here the unknown values of voltages V1 and V2. Right hand side we have to write these two values 5 and 5. So now we'll apply Cramer's rule for solving this one. So for applying Cramer's rule, first we have to find out the determinant value for this conductance matrix. So determinant delta will be equal to 3 by 4 minus 1 by 4 minus 1 by 4 5 by 12. Okay. So now 3 by 4 into 5 by 12 minus 1 by 4 into 1 by 4. Okay. So on simplification, this delta value will be equal to 0.25. So next we have to find out delta V1. So for finding out delta V1, we have to replace the first column with the right hand side matrix. So the first column will be 5, 5. The second column will remain the same, minus 1 by 4, 5 by 12. So now we have to find out the determinant, 5 into 5 by 12 minus of 5 into minus 1 by 4. So on simplification, this delta V1 value will be equal to 3.333. Now V1 is given by delta V1 by delta, that is equal to 3.333 divided by 0.25. So this will be equal to 13.33 volts. So next we will find out the value of V2. For that we have to find out delta V2. So for finding out delta V2, we have to replace the second column with the right hand side matrix. Okay. And then we have to find out the determinant value. So 3 by 4 into 5 minus of minus 1 by 4 into 5. So now on simplification, this delta V2 will be equal to 5. So now V2 will be equal to delta V2 divided by delta. So 5 divided by 0.25. This is equal to 20 volts.